Okay, now my student, we can proceed with our second session. We can proceed with our second session of our discussion. Okay, let's just start with the magnesium. Remember here we are talking about the trends which observed between magnesium and aluminum, the way we move from Mg to Al. So let's just start with in magnesium. In magnesium, the first ionization energy involved the removal of one electron from the set of paired electron from 3s orbital, which is full filled, hence more stable. You can see. Sasa tunapokuja kwa magnesium, first of all you can see that ile removing of the first ionization energy, ile electron ya kwanza ambayo anatolewa ni kwamba anatoka kwenye this 3s orbital. Sasa kama anatoka kwenye 3s orbital, hapa kwenye electronic configuration ya magnesium 3s orbital ana sifa zipi? Tunaambiwa kwamba ni fulfilled. So if it is fulfilled, maana kwamba ameattain ile electronic configuration. So you can see that here to remove the electron, the first electron, it will be difficult. Instead we apply the what? The higher ionization energy. So also this orbital explains the higher nuclear attractive force because of it is closer to the nuclear than 3p. Lakini pia tunapokuja kumwongelea 3s, remember about s. S is the most one orbital which is very closer to the what? Which is very closer to the center of the nuclear. Na anakuwa na maximum of 2 electrons. Sasa tunapokuja kuconsider 3s and 3p. This 3s this 3p is not I mean this 3s itakuwa ni itakuwa ipo karibu na nuclear. Kwa hiyo kama iko karibu na nuclear itakuwa ni sifa gani? Cha kwanza ita experience higher nuclear attractive force. It experience higher nuclear attractive force because it is closer to the nuclear once you compare with the 3p. Ukicompare na 3p. Therefore it require higher energy to remove the electron, leading to the higher ionization energy. Kwa hiyo sasa hii ndio maana kwamba unaona yenyewe inahitaji higher energy, kwa sababu kwenye 3s ni very closer to the nuclear. It's very difficult to remove the electron here because 3s and 3p is different. 3s is closer to the nuclear once you compare to the 3p. Lakini sasa also ilikuwa imeattain ile fulfilled. Kwa hiyo ilikuwa tayari ni stable. That's why there is the higher energy required to remove the first ionization energy. Sasa unaona ni tofauti kidogo. Sisi tumezoea kwamba first ionization energy inakuwa ni lower. Tumezoea kwamba inakuwa ni lower kwa sababu ile ambayo ina involve those electron or valence electron which are loosely held, kwamba always was in experience lower attractive force. Lakini tunapokuja kwenye hizi unaona kwamba ile trends yake inakuwa ni tofauti. Haifollow ile ambayo tunajua sisi kwamba ina increase from left to right across the period. Inakuwa ni tofauti. Why? Ndo hapa sasa tunasoma hizi sababu zake na reasons zake. Kwa hiyo this is for the magnesium. Now how about aluminium? So for the case of aluminium, the ionization energy involved the removal of electrons from the 3p orbital, which is partial filled with only one electron in 3p orbital. Sasa tunapokuja kwa aluminium, kumbuka aluminium ana 3 electrons. Ana 3 electrons. Sasa tunapomzungumzia aluminium utakuja kuona kwamba kwenye 3p yake kuna hizo partial filled, partial filled with only one electron in the 3p. Kwamba utaona kwamba kwenye 3p pale kuna electron moja tu ambayo imekuwa filled pale. So haijatain ile stability ya half filled or full filled. Therefore anasema kwamba and the higher in energy than the 3p orbital. So as a result the electron is removed more easily. Sasa kulingana na hiyo hapo unaona kwamba electron wake ni rahisi sana kuwa remove. Very easy to remove kwa sababu yupo nje kule peke yake mmoja. Na tukiangalia kwamba kwenye 3p na 3s is different. 3p ndio ana experience ile strong attractive force. Lakini 3p no. It is also weak. Kwa hiyo ile electron itakuwa yupo very loose. It will be easy to remove it by using the lower energy. That's why anasema kwamba as a result the electron is removed more easy, leaving a stable configuration, hence lower fast ionization energy. That's why you can see the difference in magnesium and aluminium. So I hope that is clear. That is clear. Kwa hiyo this is why this observation was made and this classification was also made ili kuweza kufanya clarification ya hizi concept. But another observation was about phosphorus and sulfur. Phosphorus and sulfur. Tulianza kuona kuhusiana na nitrogen, oxygen, magnesium, aluminium. Now let us see about phosphorus and sulfur. Okay, phosphorus has higher ionization energy than sulfur due to its half-filled electronic configuration which is stable. Sasa tunapokuja kwa phosphorus anakuwa na higher ionization energy ukikompare na sulfur kwa sababu ya kitu hiki kimoja. The issue of electronic configuration huwa ina half-filled, ina maana ile orbital yake imekuwa fulfilled with one electron. One electron ambayo ina exhibit the half-filled electronic configuration, and this one is actually stable. Hence, to remove one electron from phosphorus, higher energy is needed. Sasa kama isha maintain the stability, my dear, it's difficult to remove the electron there kwa sababu kuna ile power for stable, the stability power or the stability force ambayo ina hold zile electron katika ile stable manner. So you can see that in order to remove the electron there, it become difficult. Therefore, if it's difficult, it means that we require higher energy in order to remove those electrons. That's why you can see that there is a higher ionization energy in phosphorus compared to the sulfur. So now let us see in contrary to sulfur. Ina maana kinyume cha sulfur. Kwamba tunapomwangalia phosphorus tunasema ana higher ionization energy. How about now sulfur? So contrary to sulfur, which has unstable electronic configuration caused by a single and double occupants of the electron in the generate 3p orbital, which make it easy to remove electron. Kwamba ile generate 3p orbital, obvious, there is this kind of electron ambazo ni unstable electronic configuration. Maana kwamba sio full filled wala sio half filled. Ina maana ipo tu filled with the electronic configuration which display unstable configuration. Sasa kama ni unstable configuration, therefore it will be easy to remove those electrons without any stability. That's why anasema kwamba it easy to remove electron. Therefore, that's why when we talk about the ionization energy between sulfur and phosphorus, the ionization energy for the sulfur is always lower. This is the reason. While for phosphorus it is always higher, and the reason is because of the attainable of the stability electronic configuration, which is stable in phosphorus, while in sulfur is not stable. So my student, this is all about our discussion. And after that, I would like to say this marks the end of our discussion in both sessions, session 1 and session 2. Thank you so much for watching our Media Educare TZ. Bye bye. I wish you a nice moment.